Welcome to the session. I'm very happy to be here. My very first time in India, so I'm double excited. Hope to get a little bit of sightseeing done as well. Can we put up the slides? Here we go. So we are going to talk about one client to rule them all. And so the reason why we are here is actually Andrew, because he was writing a one-pager internally at Confluent like 2 years ago, where he was saying, the Java API of the clients is not like perfect, we could improve it. And he had a lot of good ideas, but also a lot of ideas where I was not very happy. And we had a lot of very, very cool discussions. And so we thought, it would be good to share this with the community to get feedback from you. And we want this to be a little bit, interactive and fun, and also hopefully technical. So yeah, let's get started. A little bit of history. Why are we where we are? And so originally, the old client was removed many years back. He was still written in Scala. And then it was replaced with what's called the new client. And that is the client we actually have today. And as you can see, this was introduced in 2009 release, so many, many years back. And so there's not so much new about it anymore. The good thing was it was written in Java, so we got rid of Scala. But the point is, it was still designed for Java 7, because that was back in the days. And that is one reason why we have the interface built in the way we have it now, because those design decisions are still there, right? You cannot just get rid of that. Then obviously Kafka made progress also with Java. Eventually, we did get rid of Java 7, thank God. That was introduced in Apache Kafka 2.0, but again, that was 2018, right? Very, very long time ago. And then we got like lambdas and futures. That was great. But if you go back before that, actually, Kafka did all kind of hoops to actually introduce futures and lambdas manually in Java 7. And now there's still those abstractions. So it's kind of hard to migrate off those APIs. And then finally, in Apache Kafka 3.0, it was kind of, OK, let's remove Java 8. That was proposed. And in Apache Kafka 4.0, we actually also removed Java 11, but not for the clients. Because the reasoning was that people upgrade very slowly with Java, and even more so for client applications. And now that's actually the first call out I have for all you. Upgrade your Java. That's on you. If you don't get the cool, shiny Java stuff, it's not on us. We want to upgrade, but we keep the old versions because you're too lazy to do. And so I also quote Gwen Shapiro. I love the quote. It's great. So please consider it, because then we can also move much faster with Java adoption and can adopt new Java features in the client API. And now I give it to Andrew.
Yeah, thank you. So my assertion is that Kafka clients are too hard to use. Okay, so I think people who've used them for a while kind of tolerate the way they behave, and they copy an example and that kind of thing. But you can kind of see the age of the interface in the things that it makes you do when you're actually writing your code. And that, we should really be thinking about, how kind of up to date does the interface, behave? Does it look like something which a modern Java programmer will use? And if you're new to it, is it easy to pick up, or do you just have to tolerate history because that's just the way it is? Okay, so here's a simple example. So this is just a very simple snippet of what a producer would do. So initially, it sets up a map of configurations, and then the configurations are done as key value pairs, and you have to name the configuration as a string. There are constants for it, but you're still potentially typing in a string here. You put the 3 configurations in. You need all 3 of them, right? It won't work. If you haven't got a key and a value serializer and bootstrap servers, you can't make a connection. But you kind of have to get them right and make sure they're all in your map, which is a little bit of a nuisance. And then you instantiate the Kafka producer using the configs, and there's been no checking at all that this is correct, right? We happen to be using a string serializer for the key and the value, so that means that the type variables on the Kafka producer are string, string. But if I type byte, byte there, it would have done something, right? There's no kind of, it's not tight enough to my mind, right? We can do better than that in modern Java. And then you create a new producer record, which contains hello world as the value. It's going to go on topic called topic. That's not too bad. And then you do producer.send of a record. And this returns a future, okay? So this is, in theory, an asynchronous method, which it sends the record, or it starts sending the record. It returns control to you immediately. And it hasn't necessarily completed at this point. And you would have thought, because this returns a future, this is an entirely asynchronous method. That is incorrect. It is sometimes synchronous. Okay? So if you put it somewhere where you depend upon it not waiting, every now and again you're going to get kicked in the head because it'll go synchronous. So if it's waiting for metadata, or you're pushing too hard and it's running out of memory, it goes synchronous. So it's not even a pure asynchronous interface. So, it has some kind of downsides, and there are other various problems to do with things like exception handling and that kind of stuff. But here's just a summary. So let's look at, potentially how you could do it instead. So the top 3 lines, they're using a pattern that people use in Java called the builder pattern. So I've just made up this class called Kafka client. So a new Kafka client, you do Kafka client builder, and then you say with bootstrap servers, and then the name of the bootstrap servers. And it's tightly using the right configuration name because it's got a method, bootstrap servers. And when you call the build, it could fail to do the build if you haven't set the bootstrap servers, right? It's tighter than just putting them in a map and then just, off you go. It's kind of going to give you a better developer experience. And then the next part of it is, well, we'll make a producer, and by having this thing over here, the serde string serde, we can actually have that thing have built into it the fact that it's going to be generating string data. So if you didn't use Kafka client producer string, that would actually be a compile failure. Okay, so you've now got the serializer tied to the type, which can be compile checked. Okay, so that's considerably better in terms of type safety than what we had previously. And then the third part of it is the producer.send returns now a completable future. So this is going back to what Matthias said earlier. A raw future is kind of an older way of doing it in Java. Modern Java uses a completable future, and by using the modern future style, then it's easier for handling things like completion and chaining and grouping together a bunch of completions all at the same time. So this is kind of a better way of doing it. Right, next chart, please. And that you might say, well, that was just a toy example. It wouldn't work for real code. Well, this is a more complicated one. So we've got with Sassel-Plain, and yes, we could probably make that method name a bit less ugly. But this is a user ID and password, so now we're making a secure connection. Okay. With config, schema registry. If you want to connect your schema registry, maybe you would do it like that. Now, personally, I would rather that the broker sent you the schema registry URL, so you didn't have to configure it in your application at all. But that's another story. And now, because we're going to be using a specific Avros serde, okay, so this is one which has a payment as a type variable, we can also use the payment as a type variable in the producer. So you've now got, this is how you would do it using a schema registry, using this kind of pattern. So, you can employ it in a more kind of general situation, and it works too. Right. So another thing which people kind of struggle with Kafka clients is with the sheer number of configurations which exist. It really is overwhelming if you just come along and go, oh, could I really set that? What should I set for these values here? It really has just kind of out of control, I think. So, the numbers here for the different configurations on the various interfaces, some of them are really important. Some of them you probably shouldn't touch, but people do. But you kind of end up in the reference material for the Kafka clients, trying to work out which of the ones are relevant to you. And quite a lot of them do performance, and I think really it'd be better if you just didn't have to care. If it was a bit more self-tuning and a bit less reliant on you getting magic numbers correct, then I think that would be a better thing. Okay. And again, it's a very kind of agricultural way of doing things, right? Having all of the configurations just done as kind of key value pairs. We could alternatively have a consumer config class which uses methods, kind of a similar way to before. So, default API timeout has become a method called with default API timeout. If you have a configuration that's not supported by a method, you could have a general purpose one, but basically every important configuration could have a method in there instead, and that would be a kind of a tighter way of doing it. Existing applications, of course, have configuration files containing properties, so you need to be able to support that too. So you could just support one which says, with config and a file name, and that would be a good way to do it. Because, we've got to think about how you would migrate from where you are to where we would like to be, and, we have to be, kind of have a holistic view of this kind of stuff if we're going to make any proposal. Okay.
Okay. So let's talk a little bit about producer, consumer, and admin client. And the first question is a question for you, and I hope you're awake and interact a little bit. So how many clients do you think are existing in Kafka, just for Java? 1, 2, 4. I hear 4. Do I get more? 4? No? Okay, we actually have 5, because we get the shared consumer as well. So that is new. And to make matters worse, this is just like in the Apache Kafka ecosystem. There's actually other clients, for example, the parallel consumer from Confluent. And then there is a fork of Kafka Streams from Responsive that adds async parallel runtime. So now we actually have 7 consumers. This is a little bit, or 7 clients. This is a little bit much, right? And especially the parallel consumer is something a lot of people really like, and it's going to be interesting to see how it pays out with the shared consumer getting, GA eventually, because there's obviously some overlap, but still semantics are differently. And so this is also one of those design things we're discussing, that's kind of, how do you actually get this right? You cannot shove everything into one API. That is actually the reason why the shared consumer has its own Java API, because the semantics of the existing consumer don't really fit. But then, of course, you have a lot of duplication and stuff like that, and it's just like a problem. And then, to make it worse, right, if you really say, well, you have any data system, right, why would you even have more than one client? But there's actually a good reason in Kafka why we ended up here, and it has also a lot of benefits to have small clients. And this is basically this Unix philosophy of many small tools. So when Kafka started many years back, the classic pattern you had was you have an upstream consumer producer application that is publishing data into Kafka, and then you have a downstream consumer that is reading it. So it didn't need anything more, right? It would be very confusing to have this very bad client, big client. And also, back in the days, there was still Zookeeper, so you didn't even have any admin client at all. It didn't exist. Obviously, Kafka evolved over time, and now we have much more complicated patterns. For example, Kafka Streams, where you say, I read from a topic and I write into a topic. So now having actually one client doing that is actually much more convenient instead of having 2. And so this read process write really changes a lot of things. Then also there's more like high-level APIs built on top of Kafka, like UIs. Where you say, well, I also need an admin client because I want to create topics from my UI. I want to fetch. You usually have a producer and a consumer, and it's just like it's a mess basically. And so we still don't know what we want to do, right? It's also like, as I said, a call out for the community to think about it. Would it make sense to have like this one client to rule them all and you can do everything? Would it be too clumsy? Would it be good? We don't know. So we will see. And another thing that actually came along and that makes it very hard to have multiple clients are Kafka transactions. There's very often like simple examples, and we will see one in a second. But if you actually really implement it, it's much more complicated than you might think. So this is a canonical do-it-yourself example of EOS. You start off with a consumer that would read data from a topic. You also have a producer that you use to publish your results also into the Kafka cluster. So you need to initialize the producer. Then you have your regular processing loop. You start a transaction. You use your consumer to get your first input data. Then you do some processing. You create output records. You send in. Eventually, you say, I add my offsets to also commit my progress that I made. And then I commit the transaction. Pretty simple, right? How hard can it be? OK, let's think about this a little bit more. Okay, init transaction could fail. How do you handle that case? That's not totally obvious, and if you really understand how transactions work, there's a lot of gotchas attached to that, because the producer transactional ID must be unique, there's fencing going on, and just calling init transaction can have side effects that are undesired. Then, obviously, we now have consumer.pol that most likely is running as a consumer group. So what happens if a rebalance starts while you call pol? We just call producer begin transaction before, so we're in the middle of a transaction. Now you need to take care of this, right? You cannot just remove, go on with the rebalance, you might lose partitions, so you need to have additional logic to actually commit your transaction in between, making it more complicated. And again, what happens if you cannot commit the transaction because there's another error? Then another small thing that a lot of people overlook is this, very simple call here, add offsets to transactions. You take your offset, you add them, how hard can it be? Well, it can be actually very hard, because usually your consumer is over there where Andrew is, and your producer is over here where he is. So how do you get the offsets from here to here with like 10 classes in between? Just one example. It's not so simple. Another problem, commit transactions. It could time out. What does it mean? Did the transaction commit, or did it abort? How do you handle it? How do you make sure you don't reprocess something accidentally? Those things are just there all the time. If any exception happens, you need to abort the transaction. Now you need to rewind your consumer to the right position. How are you doing that? If you rewind the consumer, you might trigger rebalance. So now all the other things also rebalance, right? So everything is interconnected, and it's very, very hard. And so that also brings me to kind of a question. In Kafka Streams, we obviously implemented that. So how much lines of code percentage-wise do you think is for error handling in Kafka Streams? 20%, 30%, 40%, I get a yes here, 50%. I mean, we don't have strict numbers, but my personal guess is 80% is just error handling. Fault tolerance, edge cases, and stuff like that. So you really do not want to do this. And the other point is also, even if you're able to do it, you build one application, you implement it, you build a second application, you implement it again. You don't want to do this. This is really gnarly. I mean, we do this for many years now, and even just recently, we found a very, very weird edge case in Kafka Streams, where we actually introduced duplicates with EOS. And I mean, it took us 4 weeks to actually find the bug. It was very, very complicated. So if you can avoid it, don't do it. So that is basically the message here.
So I find it startling that it's so difficult to write a transactional client application for Kafka. And the reason is, I think there are a few reasons. One is the separate producer and consumer clients. You have to, if you want to do a receive and then a send, you actually make two separate connections, right? And actually only the producer is transactional, which is a bit weird to my way of thinking. The consumer kind of, it has some part in the transaction, but it's not actually, you don't configure the transactional ID on the consumer, for example, right? You add offsets which were consumed into the transaction through the producer. And it doesn't actually move the kind of the offset position forward, the committed offset forward for the transaction unless it actually commits successfully, right? And as Matthias was saying, it's really hard to work out whether it's committed successfully in some situations, because you might get a timeout exception, for example. All that means is you sent it and you don't know yet, right? It doesn't tell you whether it happened or not. So you effectively have to assume that if anything goes wrong, then you have to kind of manually reset your application state. And that might be really inconvenient because, it might be distributed among the code and all this kind of stuff. So it makes it really easy to write a poorly designed transactional application because of the details. And, Matthias and I were working on the documentation that we put into 4.0, effectively clarifying all of this stuff because people in the community had implemented things and they didn't work properly and they couldn't understand why. And it's because of these kind of, vagaries, really. So, I was just imagining, what could you do to actually make it better? And this is, entirely kind of blue sky, hey, how about doing this? This isn't directly a proposal at this point in time, but, in the future, maybe we'll think about, making a proposal which could become a KIP. And this kind of idea would form part of the discussion at the very least, perhaps, even though we may never do it precisely this. So make a Kafka client, and this Kafka client is actually able to produce and consume, okay? That means we can halve the number of network connections this application makes. So this is great, okay? We're connecting the same bootstrap servers, produce and consume. This is all cool. And then we make a Kafka client processor. A processor consumes and then produces, okay? So it's like a very simple Kafka Streams application, very simple topology. It's just an in and an out, nothing more complicated than that, okay? Rather irritating, it has 4 type variables on there because it's the key and the value in and the key and the value out. So that looks a bit scruffy, but that's just Java for you. And then it makes a processor builder, again taking the SERDI, and that means all of them are strings, and we can type check them. And then you set an input topic and an output topic, and then the magic bit is you say with transactional ID. And by setting the transactional ID, you are basically saying, I want the processing to be within a transaction. Okay? And then you call processor.process, and this is a lambda, so this gets called for every record that comes in, either if a record comes in or if there's an exception, okay? And then you do your processing in here, and then you return a record which gets put onto the output topic, okay? And this is surrounded inside the Kafka client's implementation by the code to do the transaction, written correctly because the application programmer didn't need to worry about it. So you could write effectively a very simple transactional pipeline without having any of the risk of getting it wrong because the Kafka client library implementation would do it all for you. Now, I'm sure that there's a million things wrong with this and it needs an awful lot more kind of development, but I think you understand what I mean about how to kind of simplify it for a case like this. And, you know, thinking about we were talking about earlier with the fact there's a share consumer interface and there's a Kafka consumer interface. If you simplify it to this level, you could, for example, say with consumer group or with share group, because this thing is exactly the same, okay? The choice of which records you get would be different whether you're using a share group or a consumer group, but the process and logic doesn't have to be, and you then don't need to write different variants on the application depending on how you do it. It's a kind of a choice based on how you instantiate the objects. So there are kind of many kind of things you can do with this kind of pattern. It's kind of a bit like using a container around your application logic, so you don't have to write all the infrastructure yourself.
Okay. Yeah. And I mean, if you look at this code, compared to what we have seen here, this is much cleaner, right? And I mean, I think on the high level, it's a very good idea. But Andrew, you know, I kind of hate it. I mean, what's going on here? We have this already. Why are we doing this the second time? Do we add a 6th or a 7th client now? So we need to be very careful how we design that, right? That is really the message here. And I mean, making this simpler in a processor client, yes, for the user, it's great. But now I also have this, plan. Well, Kafka Streams is too heavyweight. I don't want to use it. So let's do a processor client. And now we have to re-implement exactly one semantics a second time. I don't want to do this. I already need to maintain Kafka Streams. That's hard enough. I don't want to maintain a EOS implementation with all the same bugs, or maybe different bugs, most likely different bugs, a second time, right? So from a software development point of view, we need to be very careful what we do here. And then similar, this also goes with like parallel processing, right? We know that we would really like to have parallel processing inside Kafka Streams. It would also be very valuable to have parallel processing in such a processor client, obviously, right? But then again, are we going to implement this twice? This is just a waste of engineering resources, and as you might know, Kafka is also, I mean, we ship a lot, but there's always a bottleneck, right? So we need to be very careful what we do and what we not do. And so, yeah, we had very fun discussions about that one. Because, yeah, processor client is a good idea, but we have to see how we would really do it to avoid all this code duplication. One good thing about the processor client, though, is, and that is something I love, literally love, is we have Kafka Streams only in Java. And so this is snapshots from Confluent repositories from the clients that Confluent is providing in addition to Java clients. Now, that's Liberty Kafka, .NET, and Python. And this is one of the most requested features, to add Kafka Streams to those libraries. But it's such a heavy lift, we don't really want to invest into this at this point. On the other hand, if we have a processor client that is lightweight, it might be something we could actually do. And now again, we are in the situation where it's kind of what do we really want? And that's, again, for you, right? What would you help as a developer, you know? Is this idea of a processor client good enough? Would you say, yes, let's just do it? Maybe, maybe not. We have to figure it out. So we really rely on your feedback to basically make a decision that we can say, oh, for the whole Kafka ecosystem, it's a good thing. And then we have to figure out the code duplication problem. So now we talked about Kafka Streams. This is very, very heavyweight. And I want to dig into this a little bit because it's actually something that is bothering us for a while. And it's also a fallout of how the Kafka clients are built, why Kafka Streams is a little bit heavyweight on some end. So high-level architecture of Kafka Streams is we have a Kafka Streams client instance, and you can obviously run multiple of them as a group, right? And inside a Kafka Streams client, you have those processor threads, or streams thread, how we call them. You can configure them. Usually you start with one, but you can also run with any number you want. So in addition to that, if you use a global K-table or a global store, you also get an additional thread that is called the global thread. That is maintaining this global K-table for you. So far, so good. I mean, that's just threads. That's not a problem. But now we need to look into what kind of clients do we need to use to actually make this work. So every processing thread has a consumer and a producer naturally. So we have 2 clients per thread. In addition to that, we actually also need a restore consumer for state restoration. And the main reason is the main consumer, how we call him, is part of a consumer group. So we use the subscribe pattern. We give a topic name and we subscribe. However, for restoration, we actually need to assign partitions manually. And the consumer API does not allow you to mix both. So either you subscribe or you assign. And so we need 2 clients because we need both patterns. And then obviously, we also have a global consumer for the global thread. And then every instance also has internally an admin client for all kinds of reasons. So there's an additional admin client. So now let's do the math. That's a lot. And I mean, just having a lot of clients is obviously, just from a software development point of view, not great. But what the actual problem is that every client has a network connection. So in Kafka Streams, we have a lot of network connections, and that's not efficient. For example, when you look at the producer, if you have one producer, right, you can do much more efficient batching and stuff like that. We lose all of those benefits. And that is a huge problem for us, and we would like to unify that. And the goal must actually be to reduce this. And we did some of those things already by refactoring Kafka Streams internally. So this is not completely done, but this is the vision of Kafka Streams we have, where we say, well, instead of having all those processing threads, that each have their own consumer, we just have a single consumer that is reading for all those processing threads. And then we have those new introduced processing threads in black that would do the actual work. And they could actually also now share one producer that they use together. Again, that makes EOS much harder, so we have to figure that one out. So that is something we need to consider. What we already have is, in addition, is a state updater thread that is already shipped. So the restore consumer is moving into this thread. Doesn't help us with clients at the moment. It's just like to complete the picture. And then we still have the global thread. And so this brings actually our number of network connections after we've finished this down significantly, because we now can decouple it from the number of threads n we have. And we have only like 4 clients, or maybe 5, depending if you have a global one, per instance. That's already good. But I think that's not good enough. And the goal must actually be to have only a single network connection inside Kafka Streams. But the API doesn't give it, right? We can't build it. And so one high-level idea is to say, well, we need to have some kind of a shared network client. And then like even maybe one client to rule them all, the Kafka Streams just sits on top. Or that we can basically share the network connection, because Kafka itself doesn't care. Kafka says it's a network connection. If you send a fetch request, or a write request, or an admin request, it's all the same to me. There's no reason to have different connections for that. The broker is totally agnostic to that. And so it's basically one client, and we can do read, write, admin, everything in one connection. So that is my vision. We are not there yet, and we have to figure out how we do that. And then again, it's the thing, well, we had this idea of the processor client, right? One idea is also, well, we could also like refactor Kafka Streams more and more and make it more lightweight. But then again, do we really want to refactor Kafka Streams? It's actually pretty scary. And just the state updater thread took us a year until we shipped it. So we had a kip. Now, actually, we skipped a kip, but we did the implementation. Then it was buggy. We had it feature flagged. We found bugs. We wanted to release it. We found more bugs. We kept the feature flag. So until, I think it was a year until we actually enabled it by default, since I think 3.7 or something like that. Huge performance improvements. It's actually really great. But those things are just not simple to do, right? And that is why we need to be very careful. So this is now the dilemma we have here. We have so many different clients and so many great ideas, and we want to unify them, but we don't know how. So, and the goal of this talk was really to first say, well, it would be a good idea, and we hope you like the idea, but we also want to explain why it's very complicated to do, and we hope we could carry this along. And so, as I said before, we really would like you to basically think about this and help us. And at some point, we might do a kip, right? And the more people chime in, the better. But we don't really fully understand all the applications that are out there, right? Of course, we work with customers, we work with the community, we know a lot, but we don't know everything. And getting into the mind of the developer is actually what we need to do to get this right. And so we hope you can help us with that, and we actually have prepared a survey that we would like you to fill out. So this is the QR code. We will keep it up for a while to basically help us answer this question and then prioritize those ideas correctly so that we can helpfully make this better and have either one big client or a couple of clients or whatever with modern Java and not like Java 7 or Java 8 or whatever to get a little bit more sense into that. So with that, Andrew, you want to close out?
Yeah, and I think that's true. I think that it probably isn't necessary, excuse me, to do a kind of a wholesale rewrite of the clients, right? Because there are general purpose network layers which we could basically use in other ways. So we probably can refactor things that we already have. We probably could build something similar to a processor client as effectively maybe a simplified version of Kafka Streams or something like that uses a bunch of the same infrastructure behind the scenes. It just has a simpler programming interface for simple cases. I think there are ways to take it forward, but we kind of need a bit of help to work out what good would look like. I think that's probably true. Yeah.
Okay. Yeah. Then thank you very much for joining the session, and if you have any questions, we are very happy to answer them.
Yeah, so Kafka Streams utilizes something called RocksDB for stateful computations. And at times you have seen that RocksDB becomes a bottleneck because it's a single disk that multiple threads are writing to. So are there any plans to think about improving those bottleneck due to RocksDB?
I mean, there's not anything like very concrete in the pipeline or something like that. I mean, it's always something we optimize like on the side, basically, but there's no big project going on. There was ideas at some point to maybe use a different store compared to RocksDB, but we never really did it. I mean, the good thing is the interface is pluggable, right? So you could basically plug in your own store if you really want to. I guess we would need more feedback on that. But yeah, it is a little bit of a problem also because, I mean, obviously over the years we learned a lot about RocksDB, but we are also not RocksDB developers, right? So to some extent, RocksDB stays still a black box for us. And yeah, it's very complicated to configure, but it's hard to completely avoid, I guess. But yeah, I mean, for those things, please file Jira tickets. We really, look into those a lot and, prioritize accordingly. There was a question here?
Yeah, I had a question. So can you go back to that slide where you were showing all the problems because of Kafka transaction, the timeouts and consumer rebalance, whatever. Yeah, this one, yeah. So the problem with the rebalance here is because the offset gets messed up. Is that the problem when the producer records the offset? what is the harm in having a rebalance? Because anyway, the consumer is not part of the transaction anyway.
Yeah, but you have an ongoing transaction. So let's say you read from an input topic, right? Or you read from 5 input topics, right? You start one transaction. Now, one input topic gets revoked. Now, you need to commit, because if you don't commit and add the offsets, then basically you cannot release it as a partition, but you're supposed to release it during the rebalance. And so basically you have this interaction between a transaction that is open, and now suddenly, even if you actually are not done with your work, you immediately need to say, oh, exception pass, I need to commit now, I need to clean up everything. And that is just complicated to do. And I mean, there is a callback in the consumers that you can implement and use. And that's actually also something we did at some point in Kafka Streams, where it was kind of, oh, if this callback is invoked, we do also clean up inside the callback. But that destabilizes your system, because when you are in the middle of a rebalance, the consumer is supposed to be swift and reactive and rejoins the group quickly. But now if you do all the heavyweight cleanup of your state, you block the call, and then you drop out of the consumer group, and then the mess is even bigger. And then one thing we did was at some point we said, also with incremental rebalancing that got better, we moved this out of this callback, but now basically the callback needs to basically make notes. And when the control flow comes back out of consumer poll, you need to check if this flag is set, and now you do all the cleanup in your main loop, right? So you don't block the consumer in the background, but now your control flow becomes spaghetti. And that's just like very, very complicated.
Isn't it easier to just sort of raise an exception because you're trying not to block the poll, right? In the middle of this transaction?
Yeah, you could basically also say, I throw everything away. But let's say you have processed records, and it was like an expensive computation, and then you basically roll back and throw everything away. That's a waste. It's not efficient, right?
Do you care about consistency, or do you care about just trying to finish something in a spaghetti?
Yeah, I mean,
that's what it comes down to, right?
The point is, you want to get all of it, right? And you want to get it in an elegant way. And I mean, Kafka Streams is hiding all the nitty-gritty details for you. We do this for you.
So another question I had, because I come from the database world, and I was talking to Andrew yesterday. Databases have done transactions forever.
Yeah.
And it's pretty clean, right? I mean, you would agree that it's pretty clean. So why is Kafka having such a hard time doing transactions correctly?
You want to take it? I'm very happy,
this is going to be political, isn't it? Yes. So I think part of it is I think Kafka transactions were designed specifically for kind of stream processing, right? They weren't designed to be kind of general purpose. And then the stream processing library was built probably because it was more effective way of getting things done quickly, was built on top of the existing producer and consumer. And as I said earlier, the consumer is not actually transactional. Right, and this is part of the difficulty here, I think, right? Yes, it has an isolation level parameter, but that's just that controls what it can see, not kind of what it's doing. So I think it stems from that. And this other bit, for example, this commit transaction might throw a timeout exception. Was the transaction successful or not? You don't care. That question is never answerable. All you know is it committed or it didn't, right? That's the important thing about the transaction. And you shouldn't be taking a different code path down here based on that. If an exception's thrown by that, you kind of need to check whether it happened or not care, right? But you shouldn't be trying to reason about the return from that, really, right? Because it's a distributed systems problem. So I think it's essentially that. I think it's a bit of history, and then the interface has kind of grown over time, and not really with the kind of acid kind of behavior in mind. It's kind of that. And you can restructure this a little bit to make it more simple. But Matthias's point that a real system is more complicated than this, and then you can't see it all on one screen, I think is entirely right.
Yeah. I mean, the failure at commit time with a timeout is a problem even for databases.
Yeah, absolutely.
You can die at commit, and you don't know if it committed or not until you actually restart the database and check if you knew what you were doing. So that's a known issue. But the other stuff seems to be a problem that Kafka inherited, as I guess Andrew was saying.
Can I reply to that? So the first thing you said is something I was just like sitting on my fingers not saying it because I wanted to say it. And again, this goes back now to the problem of multiple clients, right? I mean, in this case, actually, figuring out if the transaction committed or not is actually not so complicated because we have already the consumer, and that helps us. But very often, you also have an application that is producer only. And now this happens, and now you're screwed. Or you now need to create a consumer, and you need to go back to Kafka to figure out what happened. So again, clumsy and complicated, because we don't have one client. In the database, you don't have it. You have a JDB connection or whatever, and you're done, right? And I think the other point is, and that's different to databases, is those applications here that we are building, and that's what you usually don't have in databases, are inherently data parallel. And there's one big problem, is zombie fencing, that we need to solve in Kafka. That in a database system, usually you don't have, because you have your client application, it's doing a transaction. If it fails, it comes back, it can figure it out. But in our case, if we say a consumer here is dropping out of the consumer group, there's a network glitch, let's say. The consumer doesn't even know that it's dropping out of the group. We take away those partitions, we give it to somebody else. Now this consumer comes back and says, I want to commit my transaction. We cannot allow that. And so this fencing is very, very complicated because of this distributed nature of the client. And that also is part of the story why it's so complicated.
Thank you.
Another thing here is, of course, they time out, right? So if you do the begin transaction, you've got the transaction timeout basically starting from then. And the consumer.poll, if it goes into a rebalance callback, go into the rebalance listener, the time spent in there is effectively unbounded, potentially. They normally complete quickly, but you may just effectively break your transaction because you're doing a lot of stuff in there. So, it's just a bit complicated, I think. Yeah.
How does the introduction of Flink change all this? Because we're talking about Flink table API and so on, so people might slowly migrate away from Kafka Streams towards Flink?
I don't think so. I mean, there's obviously always an overlap, right? But Kafka Streams is really optimized for event-driven microservices. And I mean, the Flink table flow story is really about integrating the operational state with basically the analytical state. And when you remember the keynote from the morning, right? On the left-hand side, there was also small applications, right? And this is one of our Kafka applications. A Kafka Streams applications. So for the Kafka Streams application, nothing really changes. Because it's on the left-hand side, right? It's part of the operational thing. It might publish something. And obviously, senses with table flow might go into the analytical state, right? But for the Kafka Streams application, it doesn't really matter. It's an interesting thing, though, because Flink actually has other problems with transactions. Because those Kafka transactions are really designed for Kafka Streams in mind. And Flink actually doesn't integrate very well with it. And that is why we do have this other KIP that is called participating in two-phase commit that allows an external system to actually say, I'm in control of the transaction, I'm the transaction coordinator. And Flink can leverage that and integrate better with Kafka. But again, this is kind of an extension of the protocol to make Flink work better with Kafka, but it doesn't really affect us here. OK, I think we're coming up on time. Yep. Thank you so much for being here. Enjoy the rest of the conference, and see you around. Thank you.